Hello dear students, welcome to our virtual chemistry class. This is Mohammad Asif Iqbal, Senior Teacher, Department of Chemistry, Milestone College. Hope that all you are fine. In this class, I am going to discuss with you some of the topics taken from chapter 4, which is periodic table. Dear students, last 1 year we are going through pandemic. So this is the time to take your responsibility. And this is an ongoing effort to continue your study. So you must watch this class from beginning to end with full of concentration and prepare your lesson. And if you have any question, please ask your question to your respective subject teacher. So let's start. Now students, the topic that I am going to discuss with you is determination of the position of elements in the periodic table from their electronic configuration. So in this place we are familiar with two things. Number one, periodic table, and number two, electronic configuration. We know that the periodic table is outstanding collection of chemical concept, and in this table 118 elements are organized in such a manner that elements having same characteristics belongs to same group. And what is actually electronic configuration? The distribution of electron of an atom. And electronic configuration is provide a overall knowledge that what types of chemical reaction these elements actually going through. And it is important that we can find out one element in periodic table by its electronic configuration. So I am going to give you some of the rules through which you can find out the element in the periodic table from electronic configuration. First of all, we need to find out the period number. We know that periodic table is consist of 18 groups and 7 periods. So if you can precisely find out the period number and group number, you will be able to find out the elements, its position. So now come to the board. First of all, I am going to discuss about the first element, which is known as lithium. And from the electronic configuration, we can find out that the last energy shell of lithium, that is 2. Now come to the next one, which is sodium, 11, the total electron number or atomic number or proton number. So what is the electronic configuration of sodium? 1s2, 2s2, 2p6 and 3s1. So this is how 11 electron of sodium is distributed in its different energy shell. Now come to the third element. The atomic number of that element is 17, and how these electrons are distributed in the outermost energy shell. We can see that in the first shell 2 electrons are there, and in the second shell there are 8 electrons, and in the third shell we can see there are 7 electrons. So this is the electronic configuration of 3 different elements. First of all, we are going to find out the period number of that elements. So understand these things precisely, you need to maintain the periodic table in front of you and try to find out the element according to the rules. Now come to the first one. You can see the last electron of that element go to the second energy shell, and come to the second one, the last electron go to the third energy shell, and the third one, the last electron also go to the third energy shell. So we will determine the period number according to the energy shell number. So in the first place we can see that the electron is entered the second energy shell, and in the second place we can see the electron is entered the third energy shell, and in the third place electron also entered the third energy shell. So the period number in the first place is 2, And in the second place, the period number will be 3. And in the third place, the period number will be 3. So the period number will be the last shell number. That means the last shell where electron is entered is the period number of that particular element. Dear students, as I mentioned earlier that the total number of group in the periodic table is 18, and it is also required to find out the position of an element, and the find out the group number of an element is not like the finding out the period number. So how we can find out the group number of an element, I am going to discuss one by one. And there are several rules to find out the position of an element. Now come to the first rule. Dear students, I am going to show you some of the elements and their electronic configuration. The first one is sodium. You can see the total number of electrons present in sodium is 11, and how these electrons are distributed in the energy shell. You can see 1s2, 2s2, 2p6, 3s1. And in the second place, the second element is magnesium, and the electronic configuration of magnesium is 1s2, 2s2, 2p6 and 3s2. Now come to the third one, which is potassium, and the total number of electrons present in potassium is 19. So what is the electronic configuration of potassium? 1s2, 2s2, 2p6, 3s2, 3p6 and 4s1. So this is the electronic configuration of three different elements. So one thing we can find common in these three electronic configuration is that the last electron of these three elements entered into the 3s orbital. You can see the last electron entered the 4s orbital. The last electron entered the s orbital. So in the first two, electron entered the 3s orbital. In the last one, the electron entered the 4s orbital. So how we can find out the period number? We can find out the period number in this place by observing the number of electron in s orbital. So in the first place, you can see the total number of electron is 1. So the group number of that element will be 1. In the second place, the total number of electron in the last energy shell, that means 2s2 energy shell is 2. That means the group number will be 2. And in the third place, we can see the last energy shell is s. That's why the group number will be 1. Now come to the first thing, which is period number. As the electron enter the third energy shell, the period number will be 3. In this place, the period number will be 3, and in this place, the period number will be 4. So this is how we can find out the elements where electron enter the s orbital, or the s is the last orbital of that element. So this is the first rule, how we can find out the position of the elements. Dear students, now come to the second rule. We can see the electronic configuration of silicon, where the total number of electron is 14, and how these electrons are distributed. You can see 1s2, 2s2, 2p6, 3s2 and 3p2. Now the next one is phosphorus. The total number of electrons present in phosphorus is 15, and how these electrons are distributed: 1s2, 2s2, 2p6, 3s2, 3p3. Now come to the third one, which is chlorine. How these electrons are distributed: 1s2, 2s2, 2p6, 3s2, 3p5. So there are some similarities of the electronic configuration of these three elements. We can see the last electron entered the 3p orbital. So in this place, how we can calculate the group number? So when the electron entered the p orbital, what we will do? We'll add the electron number of last s and p orbital. In this place, the total electron is 2 plus 2, that is 4, and then add 10, and you will find the group number. And in this place, the group number of silicon is 14. Similar way, we can see the last electron is entering the p orbital. So the total number of electron present in s and p orbital is 2 plus 3 is equal to 5, and then add with 10, and then it become 15. So the group number of phosphorus also 15. Now come to the third one. The total number of electron present in s and p orbitals are 2 plus 5 is equal to 7 plus 10. So the group number of chlorine is 17. Now this is the second rule, how we can find out the group number of an element, where the electron enter the p orbital, or the last orbital is p. And similar way, we can easily find out the period number. In this place, the period number, as you can see, the third energy shell, so the period number will be 3. And also in this place, you can see the period number also 3 and also 3. So please look at the periodic table and find out the position of these elements. The silicon remain in the third period, 14th group. Phosphorus remain in the 15th period, third group, and chlorine remain in the third period, 17th group. Now students, come to the third rule. Now students, if the last electron entered the 4s orbital, which is preceded by d orbital, then how we can find out the position of the group number of that element? Now come to the first one, which is vanadium, and the total electron number of vanadium is 23. And how this electron are distributed, you can see 1s2, 2s2, 2p6, 3s2, 3p6, and 3d, 4s, 4s2, and 3d, 3. So the electron which enter in the 4s energy shell, and the previous energy shell is 3d energy shell. So in this place, the group number will be the total number of electron present in d and s orbital. So what is the number? T plus 2 is equal to 5. 3 plus 2 is equal to 5. Now come to the second one, chromium. You can see the electronic configuration of chromium 24, and that is 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. So the total number of electron present in 4s and 3d orbital is 5 plus 1, that means 6. So the group number of chromium is 6. Now come to the third one, nickel. The total number of electron present in nickel is 28. So what is the electron distribution? 1s2, 2s2, 2p6, 3s2, 3p6, 3d8, 4s2. So the total number of electron present in d and s orbital, 3d and s orbital, is 8 plus 2, that means 10. So the group number of vanadium is 5, chromium is 6, and nickel is 10. and the period number of vanadium is 4. Similar way, the period number of chromium also 4, and the period number of nickel also 4. So the position of vanadium, chromium and nickel is 5th group, 4th period, chromium 6th group, 4th period, and nickel 10th period, 10th group and 4th period. So this is how we can find out the position of an element in the periodic table. Students, come to the next topics, and the topics is electronic configurations of elements are the main basis of periodic table. I repeat once again, electronic configurations of elements are the main basis of the periodic table. Now students, what was the objective of creating the periodic table? The main objectives to creating the periodic table is to put the elements in the same group which has similar physical and chemical properties. So in this place, I'm going to discuss about how electronic configuration is the main basis of periodic table. We know that from the electronic configuration, we can find out the position of an element in the periodic table. And electronic configuration also provide the overall knowledge of the chemical properties of any element. I'm going to give you an example. You can see sodium. The total number of electrons present in sodium is 11, and these electrons are distributed in the energy shell. In this way, you can see 4s1. So you can see the last energy shell where one electron is present in sodium. So sodium tend to donate electron in the chemical reaction and become positively charged. On the other hand, you can see chlorine. The total number of electrons in chlorine is 17, and these electrons are distributed in such a way, you can see. So the total number of electrons present in the chlorine is 7 in the outermost energy shell. So chlorine has a tendency to receive electron and become negatively charged. And sodium is positioned in the first group of the periodic table because the elements which belongs to the first group has the tendency to donate electron during chemical reaction. On the other hand, chlorine is positioned in the 17th group where all the elements tend to receive electron. So from the electronic configuration, we can easily find out the chemical properties of sodium and chlorine, and also from the electronic configuration we can find out their position, exact position in the periodic table. So we can say that electronic configuration is the main basis of the periodic table, because from the electronic configuration we can find out the position of the element in the periodic table, and at the same time from the electronic configuration we can find out the chemical properties. And the objective of preparing the periodic table was to put element having same chemical property in the same group. Students, come to the third topic, some exceptions in the periodic table. The first exception is the position of hydrogen. The position of hydrogen. Now students, the main objective of creating periodic table was to put elements having same chemical properties in the same group. But in some cases, some exceptions are observed, and among them, the position of hydrogen is one. So what is the exception? Hydrogen is actually a non-metal, but the periodic table display hydrogen alongside strong electropositive alkali metal. The strong electropositive alkali metals are lithium, sodium, potassium, rubidium, cesium, francium. You can see lithium, sodium, potassium, rubidium, cesium, francium. These elements donate electron during the chemical reaction. They never receive electron. They are strong metals. Hydrogen also have some similarities with that elements, but in some cases hydrogen also act like non-metals like fluorine, chlorine, bromine, iodine. Like non-metals, fluorine remain in diatomic molecule, chlorine also, bromine also. Similar way, hydrogen also remain as a diatomic molecule. So this is not observed in the element among the element of the first group, which is lithium, sodium, potassium, rubidium, cesium, francium. And in the second place, hydrogen also receive electron. In the chemical reaction, like chlorine receive electron and become chloride ion. Similar way, hydrogen also receive electron and become hydronium ion. So hydrogen does not show all the chemical properties similar to the elements belongs to the first group. However, hydrogen also show some of the characteristic reaction like the first elements of the first group. For example, sodium, we can see actually donate electron during the chemical reaction and become sodium ion. Similar way, hydrogen also donate electron and become hydrogen ion. But the problem is that hydrogen does not always show all the properties shown by the element belongs to the first group. So the position of hydrogen in the first group is not follow the main objective of the periodic table. Now students, come to the second exception, which is the position of helium. The position of helium. Students, we know that the total number of electrons present in helium is 2. So the electronic configuration of helium will be 1s2. According to the electronic configuration of helium, helium is supposed to position in alkali earth metal. I repeat once again, helium is supposed to position in alkali earth metal, but helium is positioned with the inert gas. Actually, helium is an inert gas. It does not participate in chemical reaction. It remains inert. But the electronic configuration, if we try to organize the periodic table according to the electronic configuration, helium is supposed to position in the group 2 where all the alkali earth metal are present. But in this place, we cannot position the helium in the second group according to the electronic configuration. So this is the exception that is not follow all the rules of the periodic table. The third exception is position of the lanthanide and actinide group. Dear students, in the periodic table, third group, sixth period, there is a group present which is lanthanide group, and in the periodic table, third group, seventh period, there is another group present which is known as actinide group. So if we positioned 15th element in that place, the beauty of the periodic table is hampered. Therefore, they are placed at the bottom of the periodic table to maintain the beauty of the periodic table. So this is the exceptions of the periodic table. Dear students, hope that all you understood all the topics that I discussed in this class. If you have any question, if you have any query, please ask this question to your respective subject teacher. Thank you from being present from beginning to end.